everyone, welcome to the lecture 31 of week 11. So today we are going to talk about the advances in the climate extreme research and big data applications, a part of what emerging technologies are currently evolving in the field of climate change and extreme events, and how we can leverage those technologies to basically get more insight about how the climatic extremes have been changed, or what is their nature, what is their characteristics, what are their frequencies, or suppose what is the spatial geographical locations where these extremes are likely to occur, or something like that. So these advanced research helps us to basically utilize the available data set, historical and plus climate data set, plus the reanalysis data set, and then we can integrate all these data set together, and then we can tell about what is likely to be occur in a certain regions like that. So in this lecture we will primarily talk about what understanding a recent advancement in the climate extreme research. We will explore the role of big data in emerging technology. We will identify key data sources and tools for climate analysis, and we will also examine some case studies where big data enhanced research outcomes. So if we talk about climate extreme research, primarily we are looking at either heat waves or droughts or floods in a univariate manner, which means we are talking about a certain types of extremes where it is crossing above a threshold, or based on some sort of statistical method where we are identifying these different types of extreme events. Why it is important? Because why it is important to identify these extremes? Because it will help us to prepare some sort of adaptation strategies, and also help us to build some sort of predictive tools which can be very helpful for early warning systems and all. In the recent trends, what we have seen in the climate extreme research, these kind of the univariate which are occurring with the multiple extreme events at the same time. It could be bivariate climate extreme events, or it could be multivariate climate extremes. It could also be possible that one after another extreme events are occurring, that is called subsequent extreme events also. And also sometimes we can also say these events like compound extremes or compound events, and also tipping points where we have such changes that is irreversible to the original conditions. So at present we have the climate extremes are now evolving towards the compound extremes problem, compound events, where we are looking at simultaneously occurring of climate extremes which amplify the impact significantly. Suppose we are talking about heat waves and drought, we are talking about, let us say, heat waves and forest fire, we are talking about, let us say, cyclone and floods, we are talking about let us say coastal flooding and riverine flooding, something like that. Or if you are talking about, let us say, extreme precipitation event and riverine flooding. So these kind of the compound events which are occurring simultaneously can amplify the impact in a certain region, which basically resulted into a significant loss of the socioeconomic conditions or biodiversity in certain regions like that. The another point is we are evolving towards tipping points. Tipping points basically the critical thresholds where leading to the irreversible changes in the system. Tipping points is a kind of a threshold where system, if crosses that above that threshold, system will not be able to come back to their normal position, or that is kind of, we can say, irreversible changes in the system. So that is also very important to understand, that what are those critical threshold. If it is crosses above, the system will not be able to come back to the normal positions like that. For example, in the climate extremes or climate research, we say that +2 degree and +4 degree temperature, that is a threshold. If it is crosses above, probably the system will be behaving like a completely differently, and there will be more extremes, more intense events, and that will not behave like a normal conditions anymore if you compare to the historical data set. Then there is a integrated approaches where we are talking about comprehensive methods for studying and addressing the climate extremes through multiple sources of the data set, multiple types of modeling framework, whether it could be hybrid modeling, it could be combination of physical model plus the data driven model, sort of hybrid model, or maybe we can leverage multiple types of data set. For example, remote sensing data set, satellite based data set, reanalysis data set, the data set which we are recording at the ground station. All of these data set if you integrate together and the techniques we integrate together, we will have a more better understanding about our climate extremes. So, this is how the climate extremes are evolving in these different directions. So, first we have to discuss about what is the challenges and why we need to evolve in that direction. So, challenges in the climate extremes research are basically sometimes when we are looking at, let us say, ground observation data set. What we have observed, there is a sparse observational network in a developing region or very remote locations where for example, Himalayas, where we have very not very dense hydrometeorological stations network there, that sometimes pose a significant challenge in terms of data quality or in terms of also the reachability of those places as well. Therefore, because of these data limitations, there is some sort of variability and uncertainty also introduced in the historical data set, and when we are using those historical data set for any climate projections or climate modeling, it is likely that those regions is likely to have a more uncertainty compared to those regions where we have higher density of these dense network of the hydrometeorological data set. There is some sort of attribution complexities also we have faced, which is also pose a significant challenge, which means we have to try to disentangling the natural variability from the human induced effect. So, what is happening at the current pace is basically the nature is also show some sort of variability because of some inherent nature, some sort of natural processes, and at the same time human also introduce some sort of variability in the system. So, that is a significant challenge is how do we disintegrate these two things together, so that we can understand, okay, this is the role if the amplified by these climate extremes or any particular event is basically is human is the major governing factor, or if it is happening purely because of the natural variability, it is kind of how we can classify like this. So, this is a primary challenges in the climate extreme research as if and we are working towards it to fill those gaps. So, primarily we have data limitation where we have challenges related to insufficient or poor quality data, and there is a model uncertainty, issues arising from the unpredictability of climate models, and then there is a attribution complexity where we have difficulties in linking climate events to specific causes sometimes, whether it is because of the human factor, whether it is because of climate variability, whether it is because of some mixed effect, that is basically we have to find out. So, what is the emergence of the big data in climate science or the emerging technology? That is one area is big data. Big data is how we define, that is high volume, high velocity and high variety data set, where we have a large volume, a large dynamic data set which are keep on updating, and large variety, which means large variables it has. So, this is a kind of the data set we are currently working on, and there are lots of data set which we have created, which is the category of the big data, and we are leveraging those data set for our high end research in the climate extremes. Why it is important? Why it is relevance to the climate extreme science? Because it will enable us to analyze the long term high resolution data set and for long term analysis. Why we need long term analysis? Because let us say if you have more historical data set, more detailed historical data set, we will learn about what has happened in the historical period more accurately. And if you have higher resolution data set, which means we have precise location about where these particular climate extremes are likely to happen more frequently compared to the other region. High resolution primarily focus on the how accurately in a certain locations we can tell about the variability of the climate system or some sort of the climate extremes which are happening like that. So, what are those data sources, the big data sources? So, primary sources is satellite. Satellites are keep on revolving around Earth and collecting data from multiple places in different resolutions, in different spectral resolutions, in different temporal resolutions like that. So, therefore, satellite is a big is a good source where it is creating a lots of data set, lots of variable, and sometimes based on this satellite we have also estimating multiple secondary type of data set. For example, we can calculate multiple indexes, and that is not relevant for one particular, but that is basically you can calculate for multiple period as well, and then you can compare how that particular index are varying across time and across space. So, there is a reanalysis product we have talked about in the previous lectures, like we have ERA 5, we have TerraClimate, we have JERA 5. There are lots of reanalysis product. What is reanalysis? It is basically taking the input from some sort of observed data set, observational data set, point locations, and it is also trying to set up some sort of climate model, hydrological model, and then try to mimic the historical conditions using the some set of physical equations, and then using some sort of observational data set, fine tuning the model and then generating the result, recalibrating with the observational data set and do that analysis again when they got the satisfactory results. Once it is done, they are able to produce the product, the data set for entire world at a certain resolutions. So, what is the advantage of this? Basically, based on this product, we have the entire globe information, most area of the land area like that, and then we can basically use that data set for multiple different hypothesis testing, whether let us say what is the role of climate extremes on flooding events, what is the role of let us say land use land cover change on flood extremes or drought extremes or heat waves like that. So, this is kind of the reanalysis product we can use it. There is a sensor network which is basically ground based sensor we are developing, that is also one of the area where we are trying to get a more highly dense ground observational data set for improving our understanding in using the observational network analysis like that. And there is a citizen science data set which is basically based on some sort of survey, some sort of citizen response post disaster, pre-disaster like that, or some sort of the opinion which we are taking from the general public, and then we are also using that data set for the climate science for understanding the particular extremes or changing the extremes behavior in certain regions, or what is the impact of climate extremes on certain regions like that. So, in nutshell, what is basically the sources of big data in climate science? We have satellite data where we have atmosphere, land, ocean are monitored by different types of satellite, which can be Landsat, Sentinel, MODIS like that. There is a reanalysis product which is historical weather data and also the climate models, which can also tell us about how likely if the +2 or +4 degree temperature is increasing, how likely our different weather parameters will also behave. So, that is kind of the reanalysis product we have also have. Then there is a sensor network data where we have weather stations, dense network of weather stations, let us say in a certain region which is highly prone to some sort of climatic extremes, we can develop some sort of weather stations there, and that can also help us to understand about how the physical conditions of that particular regions are behaving. Then there these weather stations are primarily located in the land areas, and then we have ocean buoys which is also recording the data set for ocean region of multiple variables as well. Then there is a data set which is citizen science data, where we are calculating the receiving the data from citizen with the public contribution valuable information in terms of climatic streams, in terms of impact of climatic streams, in terms of let us say how the heat waves, drought or floods or some other extremes are impacting their agricultural yield, or let us say that can be also be very useful, like during the drought period what sort of the irrigation or the fresh water they are using to support the crop, or what is their overall crop yield during the drought years, like that. So, these kind of the precise valuable informations are very important to understand how a particular type of climatic streams are impacting the socioeconomic condition at the ground level, and what is their overall response. So, that is basically helpful to provide basically to some sort of impact based analysis in that regions, like that. Then there is another advancement in the analytical tools and technologies. For example, we are now moving towards era of artificial intelligence, where we have the more better predictive modeling capability. We have more better pattern recognition capability, anomaly detection capabilities. So, this has been enhanced significantly in the recent years, and which we are basically continuously growing that particular areas. Then we have cloud computing and HPC, which also make the efficient use of these predictive modeling AI generated tools like that, AI tools like that. So, these cloud computing and HPC are efficient processing of large data set. Suppose we can take example of Google Earth Engine or AWS, which is Amazon based, and then there is a geospatial analytics, where we are talking about how well we can visualize and spatially analyze the processes, or basically to visualize the effect of climatic streams, and let us say we can also do some sort of correlation analysis in geospatial analytics. So, when we are talking about the machine learning AI thing and integration of the cloud computing, we have more better predictive data processing or computing. When we have more high predictive data processing, that will help us to understand setting up the more better early warning systems, and that can help us to understand how likely a particular climatic streams are behaving or likely to occur in certain regions, like that. When we have machine learning, we are evolving, and we have also evolving at the same time geospatial analytics, which is basically also very important to do some sort of spatial predictive modeling. Spatial predictive modeling, basically we are not looking at only one location, but we are looking at multiple sites, or we are looking at multiple district level or block level or village level. And then that based on that, we are trying to look at if the climatic streams are occurring in a certain region, which area is likely to suffer more compared to other region. So, that is also kind of a spatial predictive modeling, or let us say we can also do some sort of clustering, where we can highlight those region or making some sort of zonation. This area is basically highly prone to climatic streams compared to the other regions, like that. So, that is also one of the area where we can do this kind of analysis. Advancement of the geospatial analytics and your cloud computing has also enhanced the spatial data processing. So, initially what in few decades back, what we do basically, what we did basically, we downloaded the data from satellite server itself. Once it is downloaded, that data we process with some sort of installed softwares, and based on that softwares we try to analyze the what is the anomaly, or what is the change, or what is the pattern, like that. So, in that whole process, it is a limitation of the system, what is the local computing we have and what is the memory we have. that kind of we can download or we can store that amount of data set. But that thing has been removed, the barrier has been removed as the evolution of the cloud computing, because now we have access to multiple high performance computing at your any place. We can access that computer first of all, and we can have a large storage, cloud storage, so that you can store multiple types of the data set in the cloud, and you can do some sort of, you do not have to download the data, you basically have to write a code and then it will basically implement in your data set, and that will give you some sort of spatial data processing. So what is the advantage of this? Now you would be able to do some sort of more data intensive processes, more complex algorithm analysis that can be done using this spatial data processing or advancement of the geospatial analytics and the advancement of the cloud computing. So this is one example where we are talking about heat wave predictions using artificial intelligence. So what is the objective of this? This particular research was to forecast heat wave using the deep learning model. In this particular research, the author has used the LSTM network, a long short term memory model, which is one of the famous AI tool, where we basically use for time series data set, and we use this basically model for predictive or prediction of the data set. So LSTM network was trained on the historical climate data. So what is the training means? Basically we have been trained the model, and now the model is giving a satisfactory result with the historical data set. So let us say we have given some sort of amount of data to that model, and we say to the model that okay, you learn the variability of the data set, and then you generate the historical variabilities, and then we will compare it with the historical observation data set, and then we will assess the accuracy, whether it is doing correctly or not correctly, with some sort of matrices like that. So that is a training of the LSTM or any kind of the AI model in the historical climate data. What was the outcome? Once this LSTM model was trained, we would be able to tell about, we will give some sort of more input data for future climate, and then we will tell to that model, okay, now predict what is the behavior of heat waves if we input, let us say the data set till 2026 or 25 or 30 like that, how the heat waves will behave. So that is a kind of the forecasting or predictions model of based on some sort of historically trained model, and then we are giving some sort of climate data set and using calculating the what is likely to be the, let us say, daily maximum temperature of that particular area. So this is the forecasted, so this is the observed data set, and this is the forecasted data set, and this gives you this is a kind of a threshold where it is crossing above is kind of heat waves or in a certain region, or hot extremes in certain regions like that. This is another example where we are using flood mapping with remote sensing and cloud platform. So the objective is to model or monitor the flood detection using the satellite imagery. So the input data set is your satellite imagery, the output is your flood detection, which of the area is highly prone to flooding or how much inundated area in a certain region. Cloud computing program, we are using the Google Earth Engine, that is a very famous cloud computing platform where we can analyze the satellite data set, and we can tell about how that different types of data sets are behaving for certain regions like that. What is the outcome of this research? We were able to map the high resolution flood extent mapping for the disaster response. So this is the a sort of the online layout of this Google Earth Engine, where you can write a code here, and then you can run this code with some sort of data set. Here we are using some sort of Sentinel data set, I think, and then based on that data we can run of a particular region, and then it will give you those regions which are inundated with the flooding or high flow condition. So, if you look at this particular image, it shows that wherever you have blue pixels, those areas are flooded areas, and that is basically can be considered as a flooded or inundated areas like that. Okay. And based on this data set, we can also generate some sort of time series, and that basically can give you information about how the flooded area has been moved or evolved or basically increased during the flood event, pre the flood event and the post flood disasters like that. Then there is another example of the attribution science, because we were talking about how do we if the climate extremes are occurring, how do we attribute that particular climate extremes to particular types of different processes. So, let us say that in this particular research we were estimating the human influence on specific extreme events. So, what kind of the tool the author has used, that CMIP6 model ensembles. So, CMIP6 is a kind of a future climate data set where we can take multiple models, where gives the multiple data set for a certain region. We can take the ensemble mean, a mean of the different model, and then we can also include some sort of observational data set, which is a historical data, and then we can calculate the Pacific Northwest heat wave to anthropogenic warming, and linking to the anthropogenic warming like that. So, this is a region where author has tried to look at the maximum temperature above certain threshold, and then basically try to look at what is the distribution of the data set, and then basically they are looking at different types of the time series data set and correlating with the natural variability as well as the anthropogenic warming conditions in that region. So, this is how basically we can leverage the high or big data analysis with the cloud computing. With some sort of AI tool, we would be able to tell about how the particular process are relevant to a particular type of variabilities. What is the global data platform and initiatives? So, basically there are lots of data set which are Copernicus climate data set, NASA Earth data and WorldClim. They provide multiple types of big data, which is a collaboration of Cordex, WCRP, CMIP, IPCC data distribution system center, and there are some sort of open access policies which can be used for this data for multiple different purposes. What is the role of citizen science and crowdsourcing data set? Because when we have, let us say, traditional method, we can have some sort of national statistical officer which can calculate or do some sort of survey or for different types of statistics. That can be also be useful when we are comparing the data set with our earth observation or some sort of observed data set. So, citizen science data set is very important because it will provide the what is happening in a very ground level condition and what is their impact on different societies. So, that is also one of the area which the area is evolving, and that basically also integrating with the climate extremes modeling, so that we can also have a very better insight about how the climate extremes are evolved. So, what is the future research direction in this particular climate extremes area? So, urban extremes is one of the problem, compound and cascading events, which is we have to try to understand more about these terms of processes. Technical integration, for example, IoT, artificial intelligence, blockchain for climate modeling, monitoring, and there is a policy linkages where we have to translate our research into actionable policy advice, so that it can be also applied in the ground conditions as well. What is the key takeaways of this particular lecture? Climate extremes research is evolving rapidly because of the evolution of big data and AI and cloud computing and all. Technological advancement enables better prediction and attribution, because we are now have a very high density data set, and we have a better predictive capabilities, and therefore that will enable us to do some sort of more high prediction tools or capabilities like that. And there is a open data and collaborations are key to future breakthroughs, because if we have open data set, we would be able to collaborate with the multiple other people or other parts of the people we are coming from different parts, or let us say different regions we can collaborate with, and then we can do some sort of future breakthroughs using the climate extremes areas like that. So, this is for the today lecture. In the next lecture, we will talk about remote sensing and AI in detection of climate extremes. Thank you so much for your attention.